In this video, we're going to look at some more gas laws in problem solving. We'll look at the combined gas law, Avogadro's law, and Molar volume. So let's start with the combined gas law. So the combined gas law has the equation pressure 1 times volume 1 divided by temperature 1 is equal to pressure 2 times volume 2 divided by temperature 2. The only thing that's held constant in the combined gas law is the amount of gas, but all of the other variables can change. So let's look at a sample problem. Here we have a sample of helium gas has a volume of 2.80 liters at 450 millimeters of mercury and 25 degrees Celsius. What is the new volume when the pressure changes to 700 millimeters of mercury and the temperature to 50 degrees Celsius? The amount of gas is constant. Okay, so we can go through our problem and kind of point out which variables these are. So we have here starts out with a volume of 2.80 liters. So we're going to call that volume 1. And that is at 450 millimeters of mercury. So that's going to be our pressure 1. And then 25 degrees Celsius, it's temperature 1. Now we have to remember to convert temperature to Kelvin if it is not given in Kelvin. So we'll do that before we plug it into our equation. Then it asks, what is the new volume? So volume 2 is what we are looking for. Put a question mark there. When the pressure changes to 700 millimeters of mercury. So here is our pressure 2. And our temperature 2 is 50 degrees Celsius. Again, we'll convert that to Kelvin. So let's plug in what we have so far. We have 450 millimeters of mercury. That's our pressure 1. Our volume 1 is 2.80 liters. And all of that is going to be over our temperature 1. And temperature 1 is 25 degrees Celsius. Add 273 to that to convert that to Kelvin, and we get 298. So 298 Kelvin. We're going to set that equal to pressure 2, which is 700 millimeters of mercury. Multiplying that by volume 2, which is what we are looking for. And then divide the whole thing by temperature 2, which is 50 degrees Celsius. So 50 plus 273 is going to give us a final temperature of 323 Kelvin. So we'll put that on the bottom, 323 Kelvin. Okay, so now solving for volume 2, we're going to have to move our temperature and pressure over. So to move the 700 millimeters of mercury over, we'll divide both sides by that. Let's see, get another M in there. All right. And put this on the bottom, 700 millimeters of mercury. So that cancels out over here. To move the 323 Kelvin to the other side, we're going to multiply both sides by that. Okay, so that gets rid of that. So we are left with just our volume on this side. If that gets too confusing, too messy, you can always rewrite it. But now we can just plug in all of this to our calculator. So we have 323 times 450 times 2.8 divided by the product of these two values, 298 times 700. Now you might need to put these in parentheses in your calculator when you are doing that. Otherwise, it may not work out. So just kind of keep that in mind. So once you plug all that in, you should get a new volume of 1.95 liters, rounding to 3 significant figures. Okay, now we're going to look at Avogadro's law, and Avogadro's law relates to volume and number of moles. Remember, N is the number of moles. And so we're going to look at a problem that involves this. Here's our problem. A balloon contained 0.50 moles of helium gas with a volume of 10 liters. If half of the helium escaped, what is the new volume of the balloon? The temperature and pressure are constant. And so in this example problem, you're given the number of moles of gas, but if you were given the amount of gas in grams, you would have to first use the molar mass from the periodic table to convert the grams into moles. So just keep that in mind, that N is the number of moles, and so you want to make sure that you have the correct units when you're plugging it in. Okay, so let's go through and assign what our different things are in our problem. So we have 0.50 moles of helium gas, so we're going to say that that is N1, has a volume of 10 liters, that's volume 1. Half of the helium escaped, what is the new volume? So we are looking for the new volume. We're looking for volume 2. I'm going to say we're not sure what that is. Okay, and so what would be our new amount of moles? Well, if we had 0.50 moles to begin with and half of it escaped, then we can just divide that in 2. And so N2 is going to be 0.25 moles of helium because half of our original amount escaped. So let's plug in what we have. So our volume 1 is 10 liters, and we're going to divide that by our initial amount. And so we get 0.50 moles. And we're going to set that equal to V2 and then over our 0.25 moles. Okay, so now solving for volume 2, we can simply multiply both sides by 0.25, oops, I wrote milliliters, it's really moles. Over here too, 0.25 moles. That cancels, the unit mole cancels, so 0.25 times 10 divided by 0.5, our volume 2 ends up being 5 liters of for our volume for this one. The last thing that we're going to look at for our gas laws is looking at molar volume. And what molar volume is, it just basically says at STP, and STP is standard temperature and pressure, which is 0 degrees Celsius and 1 atm. That is what STP is. So at STP, 1 mole of gas equals 22.4 liters. Well, that 1 mole of gas equaling 22.4 liters looks like we could use it as a conversion factor. And in fact, we can and will. And so we can write that as 1 mole of gas over 22.4 liters, and I just put the STP in parentheses there just to remind you that it has to be at that standard temperature and pressure. Or you can flip it and say 22.4 liters over 1 mole of gas. So let's look at a problem where we can use molar volume to help us solve this. What is the volume in liters of 45.0 grams of nitrogen gas at STP? Well, to start with, we're going to do conversion factors for this. We're going to start with the amount that we're given, which is our 45.0 grams. So I'm just going to write that down, 45.0 grams of nitrogen gas. Okay, so we want volume in liters. So we want to go from grams to liters. We don't have a direct calculation, but we can relate amount of gas to liters by these conversion factors here. So we have to first convert to moles. And so we can do that by using the molar mass from the periodic table. And so the molar mass for nitrogen, N2, remember, so take the molar mass of 1 nitrogen, multiply it by 2, we get 28.0 grams of nitrogen, and that's equivalent to 1 mole of nitrogen. All right, our grams cancel. We have moles of nitrogen left. We can use our molar volume, and we're going to put 1 mole of N2 on the bottom and put our 22.4 liters on the top. Moles cancel, and we are left with the units of liters. And I can just put into there. Okay, so now we can just plug this into our calculator. 45 times 22.4 divide by 28. And rounding to 3 significant figures, we get 36.0 liters of nitrogen gas. Okay, so that rounds out the last 3 types of problems that we might see with gas laws. So hopefully that helps you to understand how to plug in these, how to use those gas laws to plug in the problems to solve for what you're looking for.